Hello students, now today we discuss about transport protocols, that is TCP and UDP for IoT. So basically TCP is nothing but the transmission control protocol and UDP is nothing but the user data protocol, and they are the transport layer choices for Internet of Things and balancing reliability and performance. TCP provides connection oriented ordered delivery, with UDP offers fast connectionless and lightweight communication. So now we will talk about the transmission control protocol, that is TCP. So TCP is a layer 4 protocol that ensures reliability, ordered and error checked data delivered between the devices. It established the connections using three-way handshake and guaranteed all the packets arrived correctly. User uses a three-way handshake to establish the connections, breaks data into packet and resembles them in order. Retransmit lost or corrupted packets automatically retracts. It provides reliable error-checked communication. It commonly used for web browsing, email and file transfer. And the best use for this TCP is industrial control system, medical devices and firmware updates where missing data causes critical failure. So used case for this TCP protocol, for example, web browsing. So when type a URL into browser, computer uses TCP to establish a connection with the web browser. TCP ensures that HTML, CSS and JavaScript files that make up the web page are delivered accurately and in the correct order. Next use case is email. Here protocol like SMTP, that is Simple Mail Transfer Protocol, and IMAP, that is Internet Message Access Protocol, rely on TCP for sending and receiving emails. TCP guarantees that emails are delivered completely and in the correct sequence. Then used case for again TCP protocol, that is file transfer. Protocols like FTP and SFTP utilize TCP for transferring files between the computers. So this TCP's reliability ensures that files are transferred accurately without data corruption. Then next use case is remote access. So protocol like Telnet SSH uses TCP for remote access to other computers, and this TCP ensures that commands and data are transmitted reliably, allowing to interact with the remote system securely. And next is nothing but the online banking and financial transactions. So this is the another example use case for the TCP protocol. So TCP is reliability and security are crucial for online banking and financial transactions. It ensures that the sensitive data is transmitted securely and accurately, preventing the corruption. Now we will see the next protocol, that is user data protocol, UDP, in IoT. So user data protocol is a layer 4 protocol that sends data as independent data diagram with establishing a connection offering no guarantees for delivery, order or error correction. The low overhead and minimal delay makes it ideal for real-time applications where speed matters more than the reliability. Connectionless communication happens. Send datagrams without delivery or ordering the guarantees. Very low latency and overhead. No retransmission or error correction, and use for streaming, online gaming where much accuracy doesn't matter. Then some of the used cases for this UDP protocol, real-time applications. Voice over, one of the example where services like Skype, Zoom and Google Meet often utilize UDP for real-time voice and video communication. While some packet may lost, it is accepted. Then online gaming is another used case. Many online games rely on UDP for fast, low latency communication between the players and game servers. This ensures the responsiveness and prevents gameplay delay. Then next use case is video conferencing similar to voiceover. UDP is used for real-time video conferencing applications where timely delivery of video and audio streaming is essential, but accuracy is bit lower priority. Then streaming media. Live streaming services like Twitch, YouTube Live and Netflix uses UDP for streaming audio and video content. While some packet loss is acceptable, UDP speed and efficiency are crucial for delivering a smooth streaming experience. Then next use case is broadcast and multimedia. So broadcast application, here UDP is a well suited for broadcast application where a single message needs to be sent to multiple recipients simultaneously, such as network discovery protocols. Multicast applications. Here UDP is used for multicast applications where a message needs to be sent to a specific group of recipients efficiently. Like networking management protocols. So domain name system UDP is commonly used for this, where quick response are essential for resolving domain names in IP addresses. Then simple network management protocol. This protocol is used for monitoring and managing the network devices. UDP speed and efficiency make it suitable for collecting performance data for network devices. Then dynamic host configuration protocol. Here UDP is used for dynamically assigning IP address to device on a network.